All right, this hangout on air is live. Hey there, welcome everybody. Welcome once again to Astronomy Daily Live. So you can call me Cosmic, and I am a research astronomer in southeastern Arizona, where it is dark and quiet. So hope everybody's doing well out there. Everything's good here. Had a little bit of rain today, but tomorrow night, just as a warning, it looks like it might be clear. So this time of year, the live stream time, 2 hours UTC, and the time that I want to start observing are almost exactly the same. So what I've decided, to do in those kinds of cases when those overlap is I just take you outside. I grab my smartphone here and I stream off of this instead of this, and we just you watch all the shenanigans and all the messes and everything else that I'm doing out there, trying to collect data. Now I have no idea what the conditions are going to be like. The humidity might be through the roof again. It might not. Really don't know. I'm not even going to guess, right? My job is, if it's clear, I'm going to be out there, and if conditions aren't good, I'll give it a good hour or so to sort of see what's going to happen. If the trend seems to be getting worse and worse and worse, and it's like, shut it down, right? If the trend is either stable or getting better and better and better, then I will I don't know what she's up to. Then I'll just keep going. And yeah, I'll do the live stream, for a good hour or so. But, especially, well, I mean, it really doesn't matter if I've got a moon or not. The moon, it was new yesterday. So, we're going to be, for the next 2 weeks or so, maybe 16 or 17 days, I am going to have, a moon up. But that doesn't particularly matter, to the kind of work that I'm doing. So yeah, I don't think I think the only thing that's going to stop me at this point is clouds and humidity, which continues to strangely be sort of a problem here. This is the desert Southwest, and it's supposed to be dry in the desert, and well, that's not always true. I think on average, the desert is much drier, but certain times of the year, like now, wintertime here, it can definitely be pretty darn wet. So I'm going to look in the chat here really quick, make sure everything's going well there. Yay. All right, everything's cool. All right, so hope everybody's doing well. Here she comes again. Hello there. As I said, in my tweet, this is Astronomy Daily Meow, right? It's not now, it's meow, right? So yeah, she's just completely blocking my view here. Can't see the screen or anything, but we're all here having a good time. She likes to all of them like the hydrogen hydroxide almost as much as I do. And she is digging around on my desk looking for who knows what. She's got her tail on the camera, stealing the show. The one thing that I know will get her to move, she does not like these at all. In fact, when I just picked it up now, she looked at it and she's jumping away. All right. So yeah, she doesn't like that at all. Now, most kitty cats really like these, right? Really, really, because it really gives them a good thing. I don't like it though; it scratches, right? Anyway, yeah. So yeah, I'm sort of preparing for tomorrow night, and one of the things that I want to test my system on here. She's making. Oh, she's playing with that. Okay. You can sort of see her back there. One of the things that I'm testing my system on is variable stars. And yep, she's having a good time back there. Specifically, Algol type stars. The eclipsing binary stars, where you actually have two stars and they're going around each other. And component B, from our line of sight, actually passes in front of component A, and that actually makes the overall brightness of the star actually dip, right? It actually drops, and I can see that, right? And it dips for a few hours, and then brightens back up, and these kinds of binary stars usually have a period of 1 or 2 or 3 or 4, maybe up to 12 days or so, 2 weeks or so. But the actual eclipse time is very, very short. It's a matter of hours. So that's the kind of thing that can be observed in one night, or part of a night. So what I do is, and actually we can sort of walk through this a little bit. I have to decide, okay, I'm going to be starting local time here around 19 hours Mountain Standard Time, 7 p.m. or so. So what I do for variable stars is I go over to the AAVSO site. That's the American, these acronyms they always get me when I want to think of them. I can't think of them. The American Association of Variable Star Observers. So let's go over there, and I'll just show you how I found. Wait. I thought I heard something. Did you hear something? It must be those what are they called? Not Yankees, the other ones, the opposite of Yankees. What are those called? I don't know. But anyway, there he is, right there, Bobby. Bobby, what's up? What's up?
Nothing much. It's actually called a coon ass.
Okay. Did you think that I forgot about you?
Well, you was about to go share your screen. I was like, you ain't sharing no screen without introducing me first.
Well, I am really, really glad that you very, very subtly and politely gave me a little nudge to remind me that you were actually there. That was a nice, subtle way. So what's going on over there, Bobby? How you doing?
I've been doing great here. I'm traveling for the church earlier this morning. Went to Baton Rouge for a service.
Very cool. Very, very cool.
And
Yeah.
Florida, it's not Dixie, says Uncle Bill. I'd like to also welcome Andy and Ron in the chat.
All right. Cool. I need to I need to look at the chat here
Yeah, I
too.
think if you're a Dixie person, I think you're from Mississippi.
Okay. Yeah, I don't know. Yeah, well, hopefully I hope all is well there. I hope that Andy's doing well and Ron is doing well. Uncle Bill, of course, he's probably doing extremely well. He's probably doing all the ninja things. He's got, his 50 screens up and he's doing all kinds of things at the same time. I don't know how he does that, right? I mean, I can do one thing at a time, sort of. But doing 50 or 60 or 500 things at the same time, and that is way beyond me. Way beyond me. All right, now let's see. I already actually prepared for tomorrow's observations, but I will show you how I go about doing that. And so let's see, did I get over? I did get over to the AAVSO site. So I'm going to share my screen now. Share the screen, and we're going to go to infinity and beyond. And then we're going to go over to the AAVSO site. So that's just aavso.org. And, this is a great site. Great site. Excellent resource. All kinds of information and stuff. But what I do to find a variable star of a eclipsing binary type, similar to Algol, which is sort of the standard one, is I go over to this variable star index here. And so this is sort of the launch site into that, right? And then I go into search. And so now what I have to do, right, is I have to say, okay, at 7 p.m. local time, what stars are up in the sky? What sky do I actually see, right? And it can't be, it's got to be, because of the telescope I've got, it can't, be a target, that's pointing straight up, because I'm not able to see things right at the zenith. So, it's got to be, 30 degrees from the zenith or lower. Of course, it's got to be up in the sky at that time. So I just, I just go over to, Stellarium, or if I already know, what constellations are up, I'll just sort of choose there. And so I'll just sort of go through some of the constellations and look for variable stars that have certain parameters. So what I've done in this case is I have set to look at all of just the variable stars in the constellation Eridanus, which is it's sort of west of like Orion, south of Taurus. It's sort of in that area, right? And then what I also do is with my search, I can also search, or I can, list my search by various things, right? Either, like the name, if I want to search by, position, brightness, period, all that. What I'm going to do in this case is I'm going to order this by variable star type. so I can get all the eclipsing binaries all in one long list, right? So let's do that. And it's really amazing how many variable stars are out there now, that are known. It's millions, right? Millions of them.
Okay,
Now,
Uncle Bill Duran, you seen it equals a lot of field rotation also?
yes. With an alt-as mount, that's kind of a problem. The difficulty that I have, and actually I'll show you. I'll stop sharing my screen. You're not going to be able to see this incredibly well, but as you can see right now, the telescope is pointing as if it was at the zenith. There isn't enough room between here and the mount for my camera. There's just, there's no room. So I can only, point this so high up, right? It's got to be about like that or so. And then the camera, can sort of, shoot off that way instead. So field rotation really isn't the problem. The problem is that I physically I don't have enough room there to do it. So no big deal. All right, I'm going to share my screen again, and we'll go back to the AAVSO site, and I'm going to hit search. And now, Eridanus is a pretty small constellation, but it's just absolutely amazing, like I was saying, about how many just variable stars are known. Now, most of these are really faint, right? 13th, 14th, 15th, 16th, 18th magnitude, right? So, I mean, I'm not going to be able to see those. But we'll get into these a little bit, and I'll show you what's going on here. So I've ordered these by the variable type, right? So what I'm looking for is a variable type that's called EA, eclipsing algol type. So we go down here, here's D, here's E, here we go. Okay, so here's EA. Here's the first EA variable star. So then what I do is I say, okay, I'm going to look for variable stars that are, typically brighter than maybe about 12th magnitude or so, something like that, right? So here's one that's going, from 12, to 13.1. That's a little bit faint. Here's one that's, 11 to 11.7. That's not bad, right? That's not bad, but let's keep going a little bit, see if there's anything maybe a little bit brighter than that, because that's sort of right on the edge. Let's keep going here. 11.8 to 12.7, 9.15 to 9.47. I'm also, because I'm still, sort of testing things, I'd like to have, the magnitude range to sort of be as large as possible. So, like this one, right? This one is definitely really bright, but it's going, from 9.15 to 9.47. So that's only, like 3/10 of a magnitude, 4/10 of a magnitude. So, let's see if we can find something a little bit wider of a magnitude swing, right? So we're just going down, and you can see all these guys. They just go on and on and on, right? On and on and on. Now, I don't remember exactly the one that I chose, but I'm sort of curious to see if I can find it again. I probably won't be able to. But as you can see, a lot of these are really faint, and many of them, don't even have a magnitude range because they just really haven't been measured all that much. Or there's some other kind of characteristic that makes a magnitude range hard to measure, right? So let's go down here and see. These are all really, really faint, right? Really faint, but they're still all EAs, right? So these are all eclipsing binary stars, which is completely amazing. So let's see. Well, here's one that's 11.5 to 12.1. That's a little. That's not a huge range there. These are all really, really faint. Too faint to really get anything good on. EA. Okay, well now we're getting into more complicated EA stars that also have other characteristics along with them. So yeah, shoot, I'm not exactly remembering the one that I chose for tomorrow. But go back up and I thought it was one of these ASAS stars, ASAS stars. Maybe not. Maybe it was one of these assassin stars. 11.3. And if I'm not able to find the actual one, then I'm just going to choose another one here. So it doesn't particularly matter. Let's just, let's see. Let's go with, this one's not bad, right? 11.3 to 12.05. That's 0.8 of a magnitude, and it has a period of 0.94 days, right? So and actually let's take that and multiply that by 24 to get the number of hours. So 0.94269 times 24. So every 22 hours and 37 minutes, this thing goes into eclipse. So imagine what's going on here, right? You've got two stars, right? Stars, big stars that are zipping around each other and going around once every 22.5 hours. That's just mind-blowing, right? It's absolutely incredible. But apparently that's what's happening, right? Because we look at these light curves and we see now we can't see the individual stars. They are way too close to one another to be able to separate them out, right? So, but we can look at the total light that is coming from these stars and notice that once every 22 hours and 37 minutes, the light dims by 0.7 of a magnitude, right? And so the explanation that we've come up with is that, well, we've got two stars there. One star is a little bit bright, the other star is a little bit dim, and the dim star is actually transiting the bright star. It's doing this eclipse, right? And so when the fainter star blocks the light from the bright star, the combined light actually gets dimmer, right? And we can see that, right? So we sort of make a guess that it's probably a binary star doing this. Probably, most likely, we've also observed this with spectrometers, and with spectroscopy, you can actually pick out the two individual components because because one is brighter than the other, then their spectral features are going to look different, and we're actually able to discern that by looking at the spectral features versus time, and see, that things change. And so it's like, oh, okay, there are most likely two components there. But yeah, every 22 hours and 37 minutes, this thing dims for a certain amount of time. And we might be able to find out exactly what that is. So what you can do is you can actually click on the object itself and get a whole bunch of other information, right? Including the position, how it's moving in the sky, any other kinds of names, anything like that. The period again. We can actually look for light curves, and that's sort of what I'm interested in doing here. Let's see if AAVSO itself has a light curve on it. It might not. Oh, no data found for this star, so bummer on that. Let's look for another light curve here. Here's a ASAS light curve. Let's see if there's anything there. Sometimes there is, sometimes there isn't. I'm not seeing anything. I'm seeing plots, but I'm not seeing any data points. So don't know what's going on there. Get data. Okay, yeah, there is no data there. Oh well. So yeah, we may not actually get an actual light curve for this. Let's see, is there any other light curves here? Pan-STARRS data, Pan-STARRS images. I'm not seeing any other light curves though. I'm just seeing those two, and that's not giving us any satisfaction or joy here at all. So yeah, can't really even be sure about how long the actual eclipse takes place. But usually it's on the order of a few hours, right? So the final step that I do, it's like, okay, am I going to be able to see it tomorrow night, right? Well, there's an ephemeris, which is going to tell us when we think the next series of eclipses actually take place. And so these are the calculated midpoints of these events. Sometimes they'll actually, when they know, they'll actually list, when it starts, the midpoint, and then when it ends. In this case, it looks like they may not know exactly how long these eclipses take place, but they have, I guess, a pretty good handle on when they happen, right? So I'm looking at this, and of course, these times are in UT time. So I'm sort of looking here, and I'm not seeing anything great at the moment, right? Right now, it is the 7th of January at 2:28 UTC. So there is one that's supposed to be happening at 21:35, but that's like 19 hours from now. And if I take this number and subtract 7, that actually gives me my local time, which is 14:35, which is 2:35 in the afternoon, right? If the sun is up, I'm not going to see it. I don't think that star is even up at that time. So I'm not going to be able to see that. So if I sort of scan down here, right, you can see how the times change, right? And it looks like maybe around the 21st, the 20th or the 21st of January, that would be a good time for me to observe this event, because 2:20 UTC is actually what 19:20 here, 7:20 p.m. here. But of course, that is the midpoint, right? So I don't, at 7:20 p.m., I'm just beginning to get really, really dark here. So, but if these events take, several hours, then, this eclipse actually started, 1 or 2 hours before this. So probably if I were wanting, to observe this, I'd probably want to look at it, maybe on like the 19th or so, because then, midpoint is at 5:05, which for me that's 10:05 p.m. And so, yeah, I'd have a couple hours before and a couple hours after, to get a good light curve. So this guy is definitely not a good candidate for tomorrow. But I actually did find one for tomorrow. So yeah, we'll sort of see how that goes. So once I find a good candidate here, what I'll do is I'll go over to Gaia and I'll create a finder chart for myself. And with the finder chart and the coordinates, I'll be able to find this target and collect my data. So that's sort of the process there. In making an observation of a variable star, you need to know, when it's going to be happening, and then be able to see it. So of course, it has to be clear and all of that too. So all right, well, cool. So that's sort of how that goes. I'm going to stop sharing for a second.
Yeah, Cosmic. I was wondering when is the next time we're going to be experiencing a meteor shower, and what are the meteor showers we're going to have in 2019?
Oh, there's almost always a meteor shower going on. I would say, Bobby, just Google that kind of thing. I think if you Google,
but when I did a Google search, it was always pointing me to that first meteor shower we just had.
Well, if you go probably to actually, if you go to the International Meteor organization site, imo.net, you will get a list. Let's see. I'm going to share my screen again, so I'll show you where that is. Got to share the screen. Got to share the screen. By the way, in the background here is playing this week's Music from the Hearts of Space. It's episode 1132, so it's a repeat. It's a pretty good one. So hope you can hear it okay. I know, it's just coming over this microphone on the webcam, so the sound probably isn't great, but I hope you can hear it a little bit and are enjoying that. All right, so let's go over to the International Meteor Organization, and I think, let's see. Let's see if we can find. Here's a meteor shower calendar. There we go. I'll bet you that'll show all of them. So this, of course, is the one that is going on now, right? The quadratids, as they say. Now, these are probably just sort of the major ones. But yeah, I think this is a pretty good list. So, here's the Lyrids. Those are happening at the end of April. These guys also, the end of April through May. All of these have a peak, right? So you can sort of see here. I'll zoom in a little bit. So, here's the entire time span, but they peak on April 21st, right, in this case. Not a good time because the moon is going to be pretty full, so it's going to be hard to see, a lot of the fainter ones. But
So regardless of the moon being bright or not, you still can get the scatter, huh?
With the radio, yes, absolutely. The moon, I don't think the phase of the moon would have any kind of impact on that at all. So you're exactly right. Yeah. You should be able to hear them on the radio, for sure. So Edoquarids are peaking on May 4th and 5th. Good time to see those, though, because it looks like we're going to have pretty much a new moon then. So that is kind of nice. But that's not a very big shower either. 30 per hour, right, is 1 every 2 minutes, which, when you're waiting for these things to happen, 2 minutes, feels like hours and hours and hours. Anyway, here's a pretty good list of at least, the major ones, right, over the course of the next year. And, these happen pretty much at the same time every year. So yeah. So there you go, Bobby.
So which ones are usually meant for the northern hemisphere and which one's meant for the southern?
I think most of these are for the north. Meteor showers, for the most part, yeah, that's a good question because there probably are radiants in the southern hemisphere, that we up here in the north can't see. But that doesn't mean that we can't see any of the meteors from those. It's just that we wouldn't actually be able to see where exactly they're coming from. So I just thinking about that a little bit, it seems to me that we should be able to see most of these for sure. Yeah. All right, well, cool. So yeah, I think what I wanted to do was sort of continue talking about fitting data to a straight line, because this is actually one of the things that astronomers do quite a bit, is actually taking data and fitting it to some kind of a model thing, right? Now, it doesn't have to be a straight line. It can be a curved line. It can be, something else, right? In this example, which is sort of simplified. I mean, I don't like to say it that way because it's far from simple. But I just thought that I would, go through this, like over the course of a few live streams. That's one of the nice things about having a daily live stream, is that we can just sort of casually go through this. There's no kind of rush or anything like that. So let me set this up. Take a nice big swig of this HOH here. Cheers. Excellent. Okay. So let me make sure that I'm set up here. I think I still am. I want to do that. All right. Let's go for a little while here. So I'm going to share
a lot of telescopic chat in the chat and stuff.
A lot of telescope chat. You're talking about telescopes in the chat?
Uncle Bill and Andy.
What kind of live stream is this anyway? Yeah, observations need planning, um, 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 for sure. For sure, you've got to know where and when, right? That is the most important thing. If if you want any kind of success, you can randomly do things too, though, and you can do things on the fly. Nothing wrong with that. But if you want some kind of an organized effort, then planning helps a lot. And like in my case, the pointing of my scope isn't great. So the scope you know gets approximately to the right place, but it may not point exactly at the target. So it's nice to have a chart of sort of the area, so I can identify stars and actually star hop to my target. Yeah, for sure. So all right, well, I wanted to start with this um, picture again. So this is a single 2-second um, um, image that I took through my system last August, uh, of some of the stars in the open cluster called NGC 7243. And in particular, well, for this example at least, I'm looking at these three stars. This one, which I'm going to be calling target 0, and this guy here, which I'm calling target 1, and this guy here, which I'm calling target 2, right? So it's kind of hard to tell, but this guy is about half as bright as this guy, and this guy is about 1/2 as bright as that guy or so. So these are sort of the three stars that I'm looking at. And if what I did is I took a series of 200 2-second long pictures of this field, and I measured the brightness of these three stars versus time, right? And those are actually the plots that we looked at yesterday, and we can do that again here really quick. Let's see, I've got to find it. Of course, I was doing all kinds of other things here already today, so I need to go back. Here we go. So here was target 0, and you can see all the data points there. Let me zoom in a little bit here, make this a little bit bigger, like that, right? And then here's target 1. In fact, what I can do is I can actually put these all on the same plot, right? Let's do that. So let's make this 6, and this one 2, and this one 7, this one 1. Is that going to do it? I do wrong here. Oh, I totally messed that up, didn't I? Yeah, I've got to. Let me do this. I need to zoom out a little bit, just a wee bit. I'll maximize that. Sorry, I've got to do a little bit of rearranging here because the screens are fighting me. So target 002, target 1. Let's go 7. There we go. Okay, so there's all three of them on one plot, right? So we have the brightest one at the top, then a fainter one, and then a fainter one. It's kind of hard to tell looking at it like this, but what I noticed is that they're all, over the course of the night, right? They're all getting a little bit brighter, right? So here, they're around 45,000 counts, and up here they're maybe around 50,000 counts. And same with this one, right? It seems to, be getting a little bit brighter each time. This one's a little bit harder to see. So, but what I'm interested in doing is seeing if these things are basically brightening at the same rate, because I'm thinking what's happening. The moon was rising at this point, so my sky background will be getting brighter as time goes by. And when I measure the brightness of these stars, I'm actually measuring the brightness of the sky also. So I'm thinking that's sort of what I'm seeing here, is that these things are brightening because the moon is getting up and changing the brightness of the sky. So what I'm interested in doing is fitting a straight line to all of this data, and then looking at the slope of that line and seeing if the slopes are more or less the same. And my conjecture is that they probably are, but I'd like to be able, to prove that, right? So that's sort of what we're in the process of doing. And there's a way of doing that that's called fitting data to a straight line, right? So we kind of looked at this yesterday. Here is the mathematical equation for a line, right? Where B is the slope of the line, and A is what's called the y intercept. When x is 0, this is going to be 0, and so we'll just be left with A. And so what we want to do here is we want to actually find out what A and B are. And so what we can do is this method called least squares. And so what you do is you set up this equation, this one here, which, funny enough, actually uses, the Greek symbol chi. So, in the archive.org, that's why it's an X. Well, there it is right there. There is the Greek letter chi. So what we want to do here is we want to take a line, and we want to look and see, how, well, we want to look at the differences between where our line is and where the data is, right? So, drawing a line here, right, through this data, we want to sort of make sure that that line best fits the data. And the way that we do that is to figure out what is the minimum difference between our line and the data. And to minimize that, what we actually do, and I'm not going to go into any of this math, but we set the first derivative to 0, right? Oh, I hear a big echo.
Yeah, I got kicked out.
Bummer. You got kicked out. Who kicked you out?
It's probably my connection again.
Probably. So, all this math stuff doesn't matter much. For a programmer, what is really important is, okay, what do I have to do? What code do I have to write to get the answers I want? And in this case, the answers are given right here. Here's A, and here's B, right? So that's what these are, right? So this nice little book called Numerical Recipes, you know, goes through all the derivations and everything. But bottom line is that at the end, we get exactly what we want, right? So here is A, and here's B, and of course, you know, that deals with a bunch of other variables here, which of course are all defined up here. Now, I got to say before we go on that in this particular example that that I'm going to be doing, this sigma value here, which is, you know, like this O-looking thing, I'm going to have that set to 1. So we can ignore all the sigmas here, right? So just act as if the sigmas just aren't there at all, right? Absolutely none of them at all, right? Since they're 1, you know, if you divide something by 1, you just get the same thing back, right? So we can sort of ignore the sigmas in this case. So to solve for A and B, we just have to know what all these variables are: SXX and SY and SX and SY or SXY, right? And this delta value. And of course, delta is defined right here, right? So in these 3 little equations here, we have everything that we need to solve for A and B, which is the slope and the intercept of this line, right? So what are the x's and the y's? All right. The x's and the y's are the following. Let's go back to this guy. I'm going to quit out of this, and we can do this. Okay, so here's the actual data, right? And a lot of these columns we can ignore, but there are 2 columns here that are most important. This first column over here, 0, 0, 0, 0, 0, 1, 0, 0, 2, okay, these actually go up to 131. So out of the 200 pictures I took, 131 of them were, you know, decent enough to actually use, right? So I've got 131 data points here. I'm only showing you the first 20 data points in each case. So this first column here is our x values, right? So wherever you see an x, right, x sub I squared, x sub I here, right? Wherever you see an x, I'm going to use these numbers here, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know, all the way up to 131. And wherever we see a y, like a y sub I here and a y sub I there, right? That is going to be our actual data value, right? That's what this column is. So this first column is our x values, and this last column is our y values. So why does it say x sub I here? Well, because what this is, this big symbol here, that's the capital Greek letter sigma, and that specifies a mathematical sum, right? So what we're going to do is we're going to set I to 1, and then we're going to go to n, and n is just the number of data points, right? So in this case, n is going to be 131, right? So we're going to go from 1 to 131. So, so in this case, right, S sub x is going to be the sum from 1 to n of the x's. So I'm basically just going to add up all the x values here. So 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way down, right? Whatever the sum is. I don't care what it is. And that goes for all the y's as well. Now, in this case, right, sxx is actually the sum of the x squared, right? So I'm going to take the x value here in each case, and I'm going to square it, and then I'm going to add them, right? So 0 squared is 0, 1 squared is 1, 2 squared is 4, plus 9, plus 16, plus 25, 36, you know, all the way up, right? And as you can see, you know, this doesn't go in any kind of numerical order. I just noticed that. And that's because, like I said, not all the pictures I actually kept. So, you know, this is also in, you know, sort of a temporal order as well, right? You know, this is a sequential series of pictures. So, you know, pictures 7 through 17 I skipped. So that's actually a certain amount of time too. So, you know, we can actually go back to the plots here. And so you can now sort of envision this axis here as being time, and then this is the brightness, right? So brightness versus time, right? And there are, you know, I mean, it's kind of hard to see here, you know, but there are gaps, and that's what these gaps are. Actually, if we were to do something like this, 0 to 20, you'd actually see, oh, okay, yeah, let me do this a different way. Let me, we're not actually seeing it here unless I do 1 to 7 and column 1 and column 7, and column 1 and column 7. Now we'll see actual gaps. There's a big gap. In fact, let's go back to the original plot. Now we'll see actual gaps. All right, so here's a gap in the data. Here's a gap in the data. Here's some gaps here, right? Just, you know, for whatever reason, you know, those pictures weren't any good. You know, the stars weren't in the field of view. You know, maybe I bumped the telescope, and so it smeared, you know, the image out, and so, you know, we weren't seeing nice round stars. You know, for some reason I threw those out, right? And there's various reasons why. But now, of course, you can see it goes all the way to 200, right? So that's what this is, right? So we're going to take the x's, we're going to square them, and then add them up. In this case, I'm going to take x and I'm going to multiply it by y, and then I'm going to add all of those up, right? So let's go back to the data here. I'm going to take 0 in this case and multiply it by that number. And of course, I'm going to get 0. And then I'm going to add that to 1 times that. And then I'm going to add that to 2 times that, plus 3 times that, plus 4 times that, on and on and on, right? So that will give me all of these s values, right? And that's what we want down here. See, because delta in this case is s times sxx minus sx squared. And then, you know, A and B, you can sort of see, you know, what those are doing too. So let's, you I'm noticing it's almost 3 hours UTC. So let's start getting into this code, writing code, to actually do this. Now, the programming language that that I'm going to use here is a programming language called C, and there's always multiple ways of writing code, to achieve a certain goal. So what I'm going to show you is sort of my way. It definitely isn't the only way. It might not even be the best way, but it's the way that I'm going to do it, right? So I'm going to use a text editor that's called VI. Really, really, really great. And I don't know, let's call it line. So line.c. So you need to do a few preliminary things in C. You need to load some libraries. I like to load these two just as a standard. The entry point for a C program is a function that's called main, and it takes a couple of variables. One is called argv, and the other is called, well, I think it's this way, it's argc, and that. And I'm not going to get into all of this programming stuff at this point. I'm just going to sort of show you what I'm doing here. So one of the first things that we have to do, of course, is we have to load in the data, right? So here's our text file, right? And we have multiple columns, right? We have 1, 2, 3, 4, 5, 6, 7 columns, right? But I'm only interested in this first one and this last one. But I have to read them all in, right? Can't really ignore these. So what I do is I set up a bunch of variables, and I'm going to call it A, B, C, D, E, F, and G, right? And these are all going to be floating point variables, which means I can use decimal points. So A, B, C, D, E, F, and G, right? So let's define some variables. And in fact, I'm going to call it AA, BB, CC, BB, EE, FF, and GG, like that. Okay. Now, some of these variables I actually want to remember, right? So I need to store them in memory. And so what I do for that is I'm going to set up some special variables that I'm going to call XX and YY. And those are actually going to be these X's and Y's here, right? That one, and that one, and that one, and that one, right? So those are going to be floating point arrays. We also need to know the number of data points, which, at least in this case, we're calling n, right? So let's call it exactly the same thing in the code, right? Now for that, that can be a integer instead. So let's just call it an integer. I also need a counter, right? This I variable here, right? So let's do that too. Call that I, right? We also need all these S's, right? We need an S and an SX and an SY, right? We need all these. So let's do that. Let's make those floating point variables too. So let's call it S and, whoop, I don't remember what it's called, SX, SY. So SX, SY. And there's an SXX and an SXY. um, let's do it like this, just to make it a little bit easier. Oh, that. Let's call it SXX and SXY, like that. Yeah. And we also need these variables, right? And ultimately it's A and B that we're going after, right? So I'm going to make 3 more variables. One's going to be called delta, and then I'm going to call this just A and B. All right, so let's do that. So delta, A, and B.
You spelled float wrong.
Flout. Flout. All right, cool. All right, so I think we've got all of our variables here. So what I'm going to do is I'm going to tell the program what text file to open and the number of data points in there. So I can actually define my array here. And again, I'm not really going to explain this much. Just gotta deal with not knowing. Oh, there goes the doggy alarm.
Yeah, and it's supposed to be spelled CALLOC or what?
Yep. Yeah, that's a memory allocation function.
Oh, okay.
Yeah. I got that right. Doggy alarm. Wah, wah, wah. Okay. So I'm going to have 2 arguments to this program. The first one is going to be the actual name of the text file, right? So I've got 3 text files here: target 000, 001, and 002. And then I'm going to have a second argument, which is just going to be the number of rows in those text files. So argv2, that. Oh, I need one more thing. I need a file descriptor. Whoop. Just call it FA, like that. Okay. So this will open the file up. argv1, read it as a text file. That's what the RT stands for there.
And what is this ATOI for?
That's a function that converts an ASCII string to an integer. It's just another C function. Yeah, there's a lot of C functionality that I'm not going to explain. So if you have a question about it, just ask. That's fine. All right, so let's see. We're going to open that, and eventually we're going to close that. So I like to do this. And these need to go up here, like that. OK, so now what we can do is we can read in all of our data. And I'm going to do that in a while loop. And I always forget I'm looking for is the return value of this function. It's called fscanf. Is that the one that I want? I think so. I don't always remember all these function calls. So I'm going to go to here and look and see where we go. Isn't that it? No, that's not it. Isn't that it? I'll be able to get it here, I think. Scanf. Oh, okay. That is how it is. All right, cool. Now, of course, I don't remember where I was.
All you gotta do is just scroll up.
At 1906. Here we are. Okay. So fscanf, fa. Like I said, I'm not going to explain a lot of these things. This is where I actually just read in each column, right? So there's going to be an A and a B and a C and a D and an E and an F and a G. So that's 7 of them. 1, 2, 3, 4, 5, 6, 7. Like that. A, B, C, D, E, F, G is not equal EOF. So that's a big while loop there. I'm going to add another counter. Just call it J. Doesn't really matter what it's called. J0. Now we're going to set our variables. XX plus J equals AA in this case, right? We're calling this first column AA. Right? You can sort of look at that again, target. Right? So I want to grab this column and this column. Right? So that's A and G. So we're going to do that for the X's and that for the Y's, like that. And then I'm going to bump up J so I fill up my X and Y array there with AA and GG. Okay, so once that's done, then we have all of our data. So then it's just a matter of computing these S's, right? So let's just go through these one by one, and then maybe at that point I will stop because I'm noticing that it's 312 UTC. So we'll write the code, to compute all these S's, and then, we'll pick this up again tomorrow. There's no rush on this. So in this first case, right, so we can ignore the sigma down here. We have S going from 1 to N of the value of 1. So it's all we're doing is just adding 1 N times, right? So in this case, S is just going to equal N. So that's easy. Well then, because N is my total number of data points, whatever that is. I think in this case, right, it's 131, right? So let's do S of X, right? So that's a little bit more complicated. I'm going to have to put this into a loop, right? That goes from 1 to N of all the X's. So to do that, we're going to set, oh, is it SX? Yeah, okay. So I'm going to set S of X to 0. And then I'm going to make a little loop here. It's going to go. Now, C likes to start from a counter of 0 instead of 1, but no big deal. I less than N, I plus plus, like that. S of X plus equals XX plus I. Right? So X of I, that's what this is right there. It is this guy right here, right? And I'm just going to add all those up, right? It's just a sum.
Okay, Earth Radio, what math is that?
What math is this? This is just, I guess, if he's talking about this, this symbol here is just a sum, right? So we're going to go from I, from 1 to n. We're just going to add up all the x values. That's all we're going to do here. And so that's what this little loop does, is it's just adding up all the x values, right? We've read them in, and now we're going to add them up. We're going to do exactly the same for all the y's, right? So ignore the sigmas down here because those are value of 1, right? So we can ignore the sigmas here. We're just going to sum all the y values now. So I can actually just take all of this and go 1, 2, 3, 4, 5. I'm going to copy those and then just change the variables like that. Okay. There's the sum of all the y's. Okay. Now we need to sum all the x squares, right? So I'm going to take each of the x values, I'm going to square them, and then I'm going to add all those up. And those are going to be my SXX's. So 5 more of those. Like that, like that. That's going to be x like that, but I'm going to square them. So I'm just going to multiply that by exactly the same. Like that, right? X times x is x squared. And last one is we're going to take all the x's and multiply them by all their corresponding y's, and then we're going to add up all of those. So 5 more lines.
Is it like algebra asking Ert?
It's algebra, yeah. But I mean, it's a little bit easier than that because I'm not actually doing any algebra at all. It's all I'm doing is I'm just looking at these equations and doing exactly what they say. I am literally mindlessly, doing exactly what these equations tell me to do, right? Because what I want in the end, right, is to compute A and B, and A and B depend on these S values. So I have to compute them, but they're all here, right? Now, this goes through all the derivation, sort of explains, how that's done, but I'm not doing any of that. I'm just saying, this is what it has to be. I'm going to write that in the code, and that's it. That's all I'm going to do. And that's all I've done. So here's xy, x times y, just like that. So let's do one quick thing. Let's print all our s values out. So there's s, sx, sy, sxx, and sxy. SSX, SY, SXX, and SXY, like that. So this fprintf will just print those values out to the screen. That's all I'm doing there. So I think that's it. We can compile this now and run it and see what we get. Compiled the first time. That's a good sign. Okay, so run this code. We need the name of the file, which is going to be 000 in this case. And I think there's 131. Let's find out. 000. Yeah. So this first number here is the number of lines, right? So, okay, so line, target, 000, 131, bam. Okay, so S is 131. That's what it should be. S sub X is that number. S sub Y is that number. SXX is that number. And SXY is that number. So I think
works.
What's that?
It works.
Well, I think those numbers look pretty reasonable, right? You know, we can sort of do a sanity check here, right? Let's just look at the y's, right? The sum of the y's is 600 or what? 6,362,000. If we take that number, not quite sure why that's. Yeah, I'm actually sort of questioning that, because see all the decimal points here, and I'm not seeing any decimal points here, right? They're all zeros. So I'm sort of wondering if I went a little wrong here. Let's see. FA, open. Let's and this is where, you know, debugging and all that gets a lot of fun. Let's print some of these out and see. Let's just print out A and G here. Let's just make sure that, okay, so we're actually getting what looks like to be the right numbers. I'm not exactly sure why that would be such an even number like that. SX, XY. SX, XXY. Why would that be such a nice even number like that? That doesn't make any sense. It really doesn't make much sense. IJ. This is the fun part of code, and you know, this is actually where most astronomers spend most of their time, is actually debugging code and trying to figure out, like, why isn't that working the way that I thought that it should? I think one of the things is that I need to cast this as a float. That shouldn't make any difference, though, I don't think. Let's get rid of that. But you know, I'm doing this on the fly, and you're going to see all the mistakes and all the headache and everything else. So yeah, I'm a little confused as to why that's such an even number there. That's because, you know, these are fractional numbers, so I would expect to see, you know, some fractions out here too, you know, some decimal places out here. I don't expect it with the x's, right? Because those are all, you know, just regular numbers. But these have decimals, but I'm not seeing any decimals there. I don't like that. There's something definitely wrong there. Let's see. FA. Let's see. A, B, C, D, E, F, G. That's right. We were actually getting A and G there. Let's just for fun, let's print them out here. This is debugging code. Even the simplest things aren't necessarily simple. Let's just see. Make sure that yeah, it's getting all the right numbers. Fix an I. So why is that doing that? I don't know. Let's do this. Let's look at S sub y. Yeah, I'm not liking that. Not liking that at all. Let's switch these to double floating point instead. We can do that really quick here. Get a little bit more precision on these things. I don't think that that's what the problem is, but might as well do it. I guess I don't have to do it there. And let's do it down here. That. You learn to be a very, very good typist as a programmer. There we go. Still. Okay, yeah. This is probably, yeah, this is definitely okay because this is just the sum of the x squares. Okay, well, I'm happier with this now, right? Because we're actually seeing, decimal points wherever, there's a y value involved. We're seeing decimal points there. So that I'm a little bit happier with. So yeah, we can just go with that. All right. Well, I think I'm going to pause for now. I think we've got a good start. We've got all of our S's worked out. And tomorrow, all we basically have to do is just calculate delta A and B, and we're basically going to be done, right? What I want to do after this is actually go back up, to the equation for a line. Now that we know what A and B is, we can actually use those same x values to make our line. Compute y from x and actually get a straight line that should, in theory, fit the data. So we'll see if that actually occurs. So, but yeah, let's do that part tomorrow. So I will let you go for today. Let me look in the chat really quick. Yeah, there's a couple of numbers, but getting into astronomy, you gotta be very, very comfortable with numbers, definitely, because there's a lot of them and they're everywhere, right? From coordinates of objects in the sky to magnitudes to distances to all kinds of things. So yeah, you have to be extremely comfortable with numbers and manipulating those numbers and looking at numbers in many different ways. Plotting them and graphing them and all of that. So it's great fun, but yeah, you definitely have to be kind of stubborn. You have to stick to things, and I'm flying over things really fast here too. I sort of realize that, but what I'm doing is I'm just showing you, right? I mean, I don't really want to teach you, writing code and all that kind of stuff. I just want to show you what I do and what many astronomers do. A lot of astronomers spend a lot of their time writing code on their computers, and in fact, debugging code. The writing of the code is actually easy. It's just, the code rarely ever works exactly right. So it's like, oh man, and the smallest typo, right, is going to completely mess you up, totally. I've had just small typos in code run me around for weeks, right? For weeks, because it's like, what is wrong with this thing? It should be working, right? What is wrong with it? And so I test things and I debug and I think about it and, tearing my hair out. And then one day I'm looking at the code and it's like, you know what? That L should be an M. And it's like, is that all? And so I change it and everything works great. So those kinds of things happen all the time. And professional astronomers spend a ludicrous amount of time writing code and fixing code. And that's just how it is. So, all right, well, we will continue this tomorrow. So thanks for coming in, everybody. Have a great evening, a great day. Make sure to subscribe if you haven't already. You can ring that bell, to let you know that I'm going live tomorrow. It looks like it is going to be clear, so I am most likely going to be out, and so I'll probably definitely be live streaming from the scope again, and hopefully the humidity will be at least a little bit lower than what it was the other night, so I can actually get some work done. That'll be really, really nice. And I'm going to be looking at a variable star. I'm going to be looking at M77, the galaxy. And I'm going to be doing some photometry on some bright stars just to, better characterize my telescope system back there. That's sort of a longer term project, but worth doing for sure. So I've got a good lineup for tomorrow, and it's all that has to happen is that it's got to be a little bit clear. So hopefully here it goes. All right, everybody, take care. I will see you on the spin. See you later. Bye.